Hey, what's going on, guys? CodeMonkeyKinsey here. In this video, finally we're gonna implement the threefold repetitions. So that is needed in order to avoid the behavior of our engine that when it actually repeats the position while having while being a piece up. So here in Arena, unfortunately, I already have the version that actually does implement the threefold repetition. But probably if I adjust the levels back to 3 plies, I will probably be able to demonstrate you this. And by the way, that's one of the questions I have. Okay, so let's have a look. So yeah, this is the issue, and the problem here is that white is actually rook up, and even though they are rook up, instead of trying to find some winning position, it just repeats the moves, just based on the fact that white is actually better. So that's kind of it. So our goal in this video is actually to detect positions that has occurred during the game of chess more than one time, and to return the score of draw. So from the repetition detection perspective, I have no questions, because I found a very nice implementation in chess programming Wikipedia engine, CPW engine, which implements a separate table for the repetitions. So that's called like repetition hash or something like that, and then it just loops through the specific and it also implements the index to index that sort of a table, and those indices that regards to this repetition hash table. Well, it's not a hash table, it's just repetition table. So those indices are about to be incremented and decremented every time when our ply is actually incremented or decremented. So that's quite pretty trivial, and it's working. And when I am actually testing this within the console, and just in order to print whether the repetition has been detected or not, it does detect the repetition, and I'm returning the score of 0, just like it has to be basically. But for some reason I can't yet make my engine avoid these repetitions at, well, let's say at the depth of 3. So I'm not really sure, maybe this should be like that or no. So the lack of understanding of how this should be is a bit of a break here. So anyway, in this video I'm gonna bring the engine to the state where it is now, and then I'll demonstrate you kind of the difference that is there actually, and then we will go and that's it basically. So the very first thing I would like to consider, just to copy the FEN of this position to clipboard. So by the way, this is the position taken from the game that one of my subscriber sent me. I guess it was Jay, yeah. So he sent me a game. It was very kind of really lots of videos ago, before this transposition table and all this fancy stuff in the search. So BBC was playing versus a low-rated chess engine, and won a rook but couldn't mate and fell to this repetition, which was a little bit of a pain, and that happened at the depth of 8 if I'm not mistaken. What good now is assuming this transposition tables at the real depth is that we are about to encounter in the game of chess. Even without this repetition detection, it seems to be kind of plain not really that bad, but still this should be implemented. So I'll now go and make it basically, and then if some of you guys, like, by saying some of you guys, I obviously mean Harold and Pedro, so if you guys kind of see what am I doing wrong there, I would deeply appreciate if you give me a clue like what's wrong there. So without further ado, let's actually start. So I just want to, okay, so this is my source code, perfect. So let's open the terminal, and I want to type make debug, and if it compiles I want to run the BBC binary executable. Okay, but I want this in the debugging mode. plugin modes is here. And also I want to define one more position, so define repetitions, and this is the position from the clipboard. So I will now want to make use of this repetitions. And by the way, let's have a look how it's gonna look like at the depth of 10. I'm just wondering. Okay. Well, it seems like it doesn't make any repetitions at the depth of 10. Yeah, it finds a better solution, obviously. But up to the depth of 6, you see like he's trying to repeat the position back and forth. So we'll try to avoid this sort of behavior in this early depths. Okay, so I would now like to go to where the board our board representation variables actually available. Well, not here, definitely. It should be okay here. So right below the global board variables definitions, I want to create the array of oh my god, okay, let me just do this. So u64, and let's call this repetitions, array of repetitions, to store the repetition table. Okay, and this would be, well, now regarding the size, well, TSCP he has a structure called history table or history array, something like that, and it has a greater value than 64, which is the max supply. So I would probably like to use some big number like 150 to make sure there won't be any overflows. And also TSCP doesn't check for the overflows of this value in particular, so I'm not really sure if I should actually check for this overflows, and if so, then how exactly. I'm not really that sure. But anyway, and also, yeah, I just want to find where is the max supply. Okay, so it's down below here. Okay. So in this case, let's get back to the repetition table. Okay. Well, I don't know. Repetition length, how to call this? Well, I just drop it as 150 for now, just to make sure no overflows, and then I'll probably change this. So this would be the repetition table. So position repetition table, positions repetition table. Okay, and also repetition index to actually index this table. This would be the integer, obviously, so integer repetition index, and it would be equal to 0 by default, assuming that this is the global variable and assuming the GCC compiler. So in C programming language, assuming the GCC compiler global variables are pre-initialized with the values of 0. So now we need to increment and decrement this repetition index every time we are actually dealing with our every time we're incrementing and decrementing our apply. And also I just want to pre-code some stuff here, so I want to use this repetition table indexed by the repetition index, and this should be equal to the hash key, whatever hash key at that moment is available. And then we want to increment the repetition index, and then when it comes to decrementing that index, we will decrement that. Hold on a sec. I'm just wondering. So we don't we really, Yeah, hold on a sec, guys. I just want to check out one little thing here. Okay, guys. So I was actually referencing how this is done in CPW engine, like right over in here. The only thing I can't understand is why they don't update this repetition index during the null move. Well, at least where is the null move here? Null move here. So they don't update this repetition index in the null move, which is a bit strange to me. Well, at least Wise does do that, and I would be doing that as well, even though I'm not sure if that is a good idea or not, but at least it works. So that's kind of it. And also in the take back, I'm just wondering, take back, okay, hold on. Okay, move and make. Yeah, and here we just, when we are making the move, we need to, sorry guys, we need to just decrement this repetition index, and that's it. And one more little difference, that I was initially initializing this before incrementing the index, and they suggest to do this after, so maybe this would be a good idea as well. Well, anyway, so again, like, hold on a sec. So they first increment, okay, and then they write in the hash. Okay, so we'll go the same way. So here we'll say increment index and increment repetition index and store hash key. Yeah, this is it. So now I would be pasting this code everywhere where I have our apply increments and decrements, because we're doing this here. So they do this in the make move, it's done the same in the Wise, it's done the same in TSCP, but as far as I'm incrementing the plies in the search separately from make move to make it more clear and straightforward. I will need to do the same with this repetitions as well. So, well, let's make it down below every ply increment. So, well, first we'll deal with the increments, and then I'll go for decrements as well. So let's go for increments first. So here, sorry, oh, what have I done? Oh, I didn't mean this. Hold on a sec. Okay, let's start from the beginning in this case. Okay, so starting from here. Okay. Okay, paste. So just like I was mentioning, so here within the null move, well, at least this is done in Wise. I'm not really sure why is that like so, but this is done in Wise. When we're doing this null move pruning, also taking care of this repetition stuff. I don't know, maybe that's a bad idea. Well, we'll try to play around with this, trying to commenting this out back and forth to see if there is gonna be any difference. I'm just tempted to know that myself. Okay, so everywhere we have the ply being incremented, so please paste, save. So we did this in the quiescence. Okay, hold on a sec, I did this twice. Oh man, I don't need this twice. Hold on a sec, what have I done? And this is the Nigamax. Okay, so I've done this in Nigamax. Hold on a sec. Okay, in null move pruning, yeah, and the Nigamax seems to be. So here quiescence. The next is Nigamax, but the null move pruning, right? And the next one in the Nigamax itself. And then we go again. Okay, So now let's search for decrements of the ply everywhere we can find them. So let's start from the beginning. So we want to decrement repetition index and repetition index minus minus, just to make sure that we still can compile and run the code. Okay, good. What? Oh, seg fault happens because we didn't yet, decrement the index. Yeah, so it just goes some to nowhere. Okay, copy and paste. Oh man, again I missed that. Okay, don't do this twice. Oh my god, what am I doing? Yeah, I'm already tired. I am tired already. But I didn't do it here. Okay. So it should be 3 places as well. So 1. Oh no, it should be a bit more because when we make an illegal move, we need to restore this stuff back. Okay. Then here, this is the negamax, right? Okay. This is quiescence. Here, and doing this within the nullmove running, which I'll try to take this away later on to see how it's gonna be working in that case. Okay. Yeah, let's also search for this repetition index to make sure there are no duplications. Okay. Well, it seems to be just fine. Okay, so now let's go to the top of quiescence, and here I want to create a function to repetition detection, repetition position, repetition detection, and this would be the static inline integer. Let's call it is repetition, and by default, if no repetition found, I want to return 0, which means false, like no repetitions. And here I want to loop over repetition indices range, so I can say for int index equals to, well, I guess 0, right? Index is less than a repetition index and index plus plus. And here, if we found same hash key in if we found the hash key same with a current, so if and repetition table indexed by the index is equal to hash key, in this case we found a repetition, so we want to return 1, which means true. So okay guys, let me just quickly check this. I just want to make sure that I did implement that correctly. So it's done within the search, and repetition is repetition. Okay, yeah, so it's if it's equal to the current cache, yeah, return 1, otherwise return 0. Okay, so this is good. Okay, so well, now it shouldn't be given this segfault, because now indexing should be just fine. Well, perfect. And we didn't yet do anything with the scores, because we actually didn't check for the repetitions. Perfect. So sometimes people do a check for repetitions in the quiescence. So well, let's say here, like, if is, well, actually we need to make sure that the ply is not the reply, but in quiescence search it's hard to imagine the situation when the ply is not it's always be greater than 0, because we at least make one move, so probably we don't even need this condition. Well, anyway, just let's leave it. So if ply and is repetition, so here return 0, so returning a draw score. As I remember, it doesn't really do much, so you see, like, this repetition are still kind of the same, so it's not doing much. But Wise, for some reason, is trying to detect the repetitions in the questions. I have no idea why this is happening, so to me it's like kind of a slowdown, which is not worth it really. So if only if somebody would tell me that this is really important, I would definitely do it, but at this moment I can't see much reason for doing this. So where I want to do this is within the quiescence, just right before here, right before dealing with just right before reading the hash entry from the hash table. So let's say if position repetition occurs, in this case we just want to return draw score. Draw or draw? Well, let's make it draw. Return draw score. So it means like 0. And now already it should be, well, let me just get rid of this reply. So it now already should be changing this repetitions. Oh, by the way, even without that, it's changing for the opponent. Well, that doesn't matter really. So we are now tracking this up to the depth of 6, or even hold on a sec. So many. Up to what depth do they occur in? Up to the depth of 7. Well, at some point. Okay, so let's see what is gonna be what is gonna change now. Okay, so you see, like, it still has this repetition up to this depth 3, but then it actually doesn't. It actually changes the PV line and go in a different path. So just to give you an idea when in particular these repetitions are encountered, I just want to show you the tests I've been doing. So repetitions. Okay, repetitions. No, here. Next. Oh man. Oh, it's too long. Okay, so is repetition here. So if instead of this return we just print like found repetition, Just want to give you an idea where it finds these repetitions. So it really kind of finds a lot of them. Well, at least it was when I was testing this stuff. Okay, so just want to start from the very beginning. Okay. So this is what I wanted to show you guys. So it starts finding these repetitions starting from depth 2, where they actually do occur. So the very first repetition occurs here, or yeah, it seems like. But anyway, I'm not really sure why, even though he says this repetition, the PV line is changed. I was asking this question on TalkChess forum, but didn't really yet get any decent answer at this point. So if you guys, by saying you guys, I mean Pedro and Harold, if you know, like, is this the intended behavior or not, please let me know. So it seems a little bit strange to me, but we have what we have here. So already starting from the node 4, we are going for a different principal variation line, and at the depth of 5 we're going even more different. So if I now show you this in Arena, well, before testing this in Arena, I just want to I want to go for one more little test. So I'm just wondering what's gonna happen if we don't deal with this repetition indices within a null move. So is this gonna be a different story here? I have no idea how this should be done, to be honest. Again, like, Wise does this in the null move. I just want to, well, I can show you this to ensure you, basically. So have a look how this is done in Vice. So source of the Wise, and just go to null move. Well, actually it's not here. But hold on a sec. Wise actually is using what is known as the history ply, which is also used, not only for make move, which is not only used for the repetition detection, but also for, this is what I mean. So he does this history data storing, and storing this position key. And hold on a sec, he does this before checking for an in peasant. And what do I do? Well, I do the same. Okay, this is good. And what he also do here, he increments this history ply after changing the site. Well, I don't think that this matters that much. So yeah, CPV does this before, and Vice does this after for some reason. But the results are literally the same, so it's hard to say what way of doing things is actually better. So yeah, I would actually leave this version, because again, like, I have no idea how this should be. It's incredibly difficult to do something when you don't know exactly how the result should look like. So if this behavior is okay or not. Okay guys, so I will now, so did I do anything correctly? So I will now try to run the arena and show you what has changed. So we've been testing this at the depth of 4. Well, actually we were testing this at the depth of 3, where it always returns the repetitions. And unfortunately this would be the same now as well. But at the depth of 4, so you remember, like, the principal variation line, so if we don't even have this repetition, so starting from this, like, depth 4, we're gonna be searching another different things here. But here up to basically depth, oh not this one, sorry, well, some early versions, I mean some early versions, well, okay, hold on a sec, I'm still in the debugging mode, I guess. Okay, yeah, I didn't check that, change that. Well, you remember, like, we did have the repetitions up to depth 7, I guess. Well, at least up to depth 6, but now we don't. So now we have a different principal variations here, which means that it would be working now just kind of fine. But anyway, before anything else, I just want to enable the release mode back, and let's make the source again. So just to make sure that everything would be working, I want to restore the arena again one last time. Well, maybe not necessarily needed, but still. Okay, so levels 4, okay, and position, no, engines, manage, details, and here I want to go to chess programming source and threefold repetition. Oh, sorry. Okay, this one, open. So you see, like, now it makes a different move at the depth of 4, while it was kind of trying to check this, go for this infinite check, perpetual check before. So now he would be playing a couple of moves, but he will fall into another repetition quite pretty soon. Well, this is how it was. Yeah, you see, like, it falls into another repetition, and again, like, it's hard to say why this is happening, but if we actually now go to adjust, like, the 5 plies, now this would be this would already be enough to actually win this game eventually, which is good. So just want to show you the game basically. So you see, like, now it's gonna win, and there are no repetitions in the principal variations, which is actually good. So again, like, it's hard to tell whether it's okay or maybe not okay. Probably it's not really that great. Yeah, so this is the exact mate I saw there. And again, like, assuming the real even the blitz game, well, let's say, okay, just drop that position. Okay, doesn't matter. I just wanted to show you that in that position, well, let me actually, can I try to, yeah, this is the game. This is the, sorry. So this is the game. So starting from here, so if we are going for some real-time controls, and by the way, what would be the time control here? Some tournament mode. So it was done automatically, or what? I'm not sure. Well, anyway, so if we just ask our engine to play with a huge depth, we obviously would. Oh, guys, I hope the video is still being recorded. So this something is happening to my system from time to time. Okay, come on. Yeah, so we're right. Depth 12. Okay. So assuming this kind of real depth, it's not going for the repetitions, because even if it finds this repetitions, it just sees the better continuations rather than just move the pieces back and forth. But again, like, I'm really confused by these results, because the implementation seems to be correct, while I'm not really sure, like, does engine is this okay that engine actually kind of does this repetition at the depth of 4 ply? Well, obviously nobody would be playing at the 4 ply ever, even at 5 ply, so it would at least be like 7 ply or 8 plies at least. And with those depths, it's literally enough to have, like, you know. By the way, you see, like, it's not really exchanging the rooks at the moment. It just really goes for different for some different continuations here, which is quite pretty nice. So it's not changing the rooks. So this is a different game already, and you see, like, it's not repeating the moves, which is good news, obviously. So guys, if you know, like, what am I doing wrong here, please kindly let me know. I will deeply appreciate that. And well, so any ideas, criticism, all this is appreciated, because it's really hard to say. So while it's playing, I just want to quickly walk through the source code again. So what did we add here? So to highlight the implementation, so we did this repetitions, create the repetitions table and the repetition index, and then we just increment in this index, and then storing the appropriate hash key. We're doing this in the quiescence, in the nullmove pruning, in the increment search. That's it. And then, if in order to find the repetition, we're looping over the range of this repetition index, and if current hash key is available to someone available there in this history of repetitions, then we'll return true. And then in the increment search, we just return 0 in case if the ply is not root ply, and the repetition returns true, so we just return the score of 0. And you see, like, it does affect the principal variation, so it's not always going for those repetitions, but still a bit unclear, like, how it should be actually. Okay, and this is yeah, BBC made it when I was talking, so let's just see what the mate was. Yeah, it was quite pretty interesting. So okay, let's try to Quinn. Okay, and this is made. Yeah, quite pretty nice. Okay. Okay guys, so this is it from my side. I really hope that you help me to figure out what's wrong, if any, or if this is the behavior that should be. Well, maybe this is just okay, I'm not sure. So depending on what you think on this point, I would either work on these repetitions more, or otherwise I will go and work on the evaluation function. And there we would be quite pretty close to the very first initial release of the very first version of our Bitboard chess engine in C. And that's it. So I hope to see you in the next videos within this series. Have a good day, or probably night, depending on the time zone. So hope to see you in the next videos. Until that time, and take care.